Okay, we're looking at practice 11F, which is called the combined gas law. This is going to take, of course, all three gas laws, Boyle's law, Charles' law, Ginnell's law, and combine them into one equation. And so we know this equation looks like this, and I've gone to great trouble to show you how to derive this equation to get the variable that you want to find. So all you have to do is follow these directions. You want P2, divide both sides by V2, and then multiply both sides by T2. You want to find T2, cross multiply to get T2 by itself, and then divide both sides by P1 and V1. Or if you want to find V2, divide both sides by P2, multiply both sides by T2. All right? Not only that, but I've derived the equations for each individual problem. Don't expect me to do this on a quiz or a test. And the last thing you want to remember is that every time you see the letters STP, they stand for something called standard temperature and pressure. And of course, standard temperature is always 0 degrees Celsius, but you got to get that into kelvins. Also, standard pressure is 1 atmosphere, or 760 millimeters of mercury, or 101.3 kilopascals. All right, that's all you need to know. So we're going to practice this, and because I like to establish my variables, I'm going to do that over here on the left. Here's question number 1. At STP, a sample of N2 gas occupies 50 liters. Right off the bat, we know V1, 50 liters. We know P1, 1 atmosphere. We know T1, STP, 0 degrees Celsius, otherwise known as 273 kelvins. Okay, STP. P1, 1 atmosphere, STP. T1, 0 degrees Celsius, STP. The question is asking for the new volume. We're going to change the pressure from 1 atmosphere to 90, and we're not really changing the temperature. It stays at 0 degrees Celsius, but we're going to do it anyway. So the question is asking us to find V2. It's right here, but I'm going to show you how I do it. So if we know P1 times V1 over T1 is equal to P2 over V2 times T2. To get V2 by itself, I'm going to multiply both sides by T2. That gets rid of it over here. Then I'm going to divide both sides by P2, and that gets rid of it over here. So now what you have is V2 is equal to T2 times P1 times V1 over T1 times P2. It's right there. I did it right here. So I'm going to show you how I'm going to plug all this stuff in and how the units cancel to get our answer. So we're going to say V2 is equal to P1 V1 T2. P1, 1 atmosphere. V1, 50 liters. T2, it's the same thing as T1, but 273 kelvins. This is over T1 P2. T1, 273 kelvins. P2 is 90 atmospheres. Make sure we did this correctly. Atmospheres cancel, kelvins cancel. The only unit that's left is liters, and that's of course what we want because we want our answer to be in volume. I'm going to instruct my calculator to do everything in parentheses so the order is correct. Let me show you what that looks like this first time, and then I'm not going to turn this on again because you'll have seen how it works. Okay, so in my calculator I'm going to put on the top in parentheses 1. I'm going to multiply this by 50. I'm going to multiply this by 273. I'm going to close the parentheses. Then I'm going to divide by 273 times 90. And I'm going to close these parentheses. This tells the calculator to do things in the right order. Take everything on the top, multiply it. Take everything on the bottom, multiply it, and then divide those two. So here is our answer in liters. 0.56 liters. 0.56. Okay? That's all you do. So I'm not going to turn on the calculator, and I'm just going to show you how I'm doing each of these. I've already shown you how I set up each of these equations. Not only that, but they're all right here. Oh, they're not right there. Well, let's do this one. It says here, what pressure would you have if you had to exert 5 liters of a gas at STP? What pressure would you have to exert on 5 liters of a gas at STP? V1, 5 liters. P1, STP, 1 atmosphere. T1 is 100 degrees Celsius, but we're going to, T1 is STP. See? Easy to get these things mixed up. That's why it's good to identify these things. T1, STP, 0 degrees Celsius, otherwise known as 273 kelvins. We are trying to keep the volume the same, so we're going to keep the volume at 5 liters. But we are asking what is our new pressure if we increase the temperature T2 to 100 degrees Celsius, otherwise known as 373 kelvins. All right, you've seen me do this. P1 times V1 over T1 equals P2 times V2 over T2. I want P2, so to get P2 by itself, I'm going to divide both sides by V2. That gets rid of it over here. Then I'm going to multiply both sides by T2, and that gets rid of it over here. So that means P2 is equal to T2 P1 V1 over T1 V2. It's right here, so I'm going to erase this, and I'm going to plug everything in. We're going to say P2 is equal to P1 V1 over times T2. P1 we said is 1 atmosphere. V1 we said is 5 liters. T2 we said is 373 kelvins. We're going to say T1 is our initial temperature, 273 kelvins, and V2 is staying the same, 5 liters. Let's double check to make sure everything cancels. Kelvins cancels. Liters cancels, leaves our answer in atmospheres. I've already showed you how to use the parentheses in the calculator, so I'm going to say in parentheses 1 times 5 times 373 divided by, in parentheses, 273 times 5. I get a pressure of 1.37 atmospheres. Okay, these don't show the equations. You're going to have to try this. It says you take your pet helium balloon Melvin to the local training center for astronauts. One of the trainees has kidnapped Melvin and taken him into the hyperbaric freeze chamber. If Melvin occupies a nice healthy 3 liters at 25 degrees Celsius and 1 atmosphere, what will his new volume be at negative 50 degrees Celsius and 5 atmospheres? We got a V1, 3 liters. We have a P1 of 1 atmosphere. And we have a T1 of 25 degrees Celsius. We're going to add 273 to get that into kelvins. We're trying to find the new volume, which is V2, at a new pressure P2 of 5 atmospheres, and our new temperature of negative 50 degrees Celsius. We're going to get that into kelvins by adding 273 to negative 50, and of course that's 223. So I'm trying to find V2. If we know P1 times V1 over T1 equals P2 times V2 over T2, I want to get V2 by itself. That means I got to divide both sides by P2. That gets rid of it over here. I didn't mean to get rid of that. Now we're going to multiply both sides by T2, and that gets rid of it over here. That means V2 is equal to T2 times P1 times V1 over T1 times P2. Not there. So what I'm going to do is I'm going to write this here. T2 times P1 times V1 over T1 times P2. So now that I have that, I'll set this up to solve for V2. We said it's T2 times P1 times V1. T2, 223 kelvins. V1, 3 liters. P1, 1 atmosphere. I think I like that better in green. We're going to say V2 is equal to T2, which we said is 223 kelvins, times P1, which we said is 1 atmosphere, times V1, which is 3 liters. On the bottom is T1, that's 293 kelvins, and P2, which is 5 atmospheres. Let's verify that this works. Atmospheres cancels atmospheres. Kelvins cancels kelvins, leaves our answer in liters, which is volume. That's what we want. So I'm in parentheses, I'm going to say on the top, 223 times 1 times 3 liters, in close parentheses, divided by, on the bottom, in parentheses, 293 times 5. We've already verified the equation works, and I get 0.46 liters. Okay? All right, last one. This one's asking for original volume right off the bat. That tells you you're looking for V1. We have a combined gas at STP. That means P1 is going to be 1 atmosphere. T1 is 0 degrees Celsius, otherwise known as 273 kelvins. It has a new volume of 700 milliliters, and we are changing the temperature to 45 degrees Celsius. That is 318 kelvins. And we're changing the pressure to 0.7 atmospheres. So, we're looking for the original volume that it would have at STP, if these are the conditions that it has a volume of 700 milliliters. So we're trying to find V1. All right. If we know, apologize, P1 V1 over T1 equals P2 V2 over T2, and I'm trying to find V1. I'm going to get that by dividing both sides by P1. So it's going to get rid of P1 over here and puts it underneath here. Now we want to get rid of T1, so I'm going to multiply both sides by T1, and that gets rid of it over here. That tells you that V1 is going to be equal to P2 times V2 times T1 over T2 times P1. All right, let's plug everything in. So now we know how we got it. We're solving for V1. We'll say P2 times V2. P2 is 0.7 atmospheres times V2, which is 700 milliliters. You're going to say, do we have to get that into liters? You'll find out in a little bit. We're also going to multiply that by T1, which we're going to say is 273 kelvins. On the bottom, we are going to put T2 and P1. T2 we said was 318 kelvins, and P1 we said was 1 atmosphere. So let's find out. Do we have to get that into liters? Atmospheres cancels, kelvins cancel, leaves our volume in milliliters. Nothing wrong with milliliters because it can't be negative. So we're going to put this in parentheses, and I'm going to say, in parentheses, 0.7 times 700 times 273. And I'm going to divide this by, in parentheses, 318, of course, times 1, which I don't need to do. Here is my new volume, 421. And that's all you do. See you later. Have a good weekend.